welcome back to another episode of the Ruby Rogues podcast. This week on our panel, we have Valentino Stoll.
Hey, you know.
Charles Max Wood from Top End Devs. We've got a special guest, and that is Samuel Williams. Samuel, do you want to introduce yourself? Let people know who you are and why we all love you.
Thank you. My name's Samuel. I live in New Zealand, and my cat's right here with me. It's like the morning routine, and I'm having a coffee, which is awesome.
What time is it in New Zealand?
Yeah, it's 8 a.m.
Oh, okay.
Well, not a little past 8 a.m. actually, but anyway, close enough.
Oh, I was imagining it was like 4 a.m. or something, so I don't feel guilty anymore.
I have had meetings at like 4 a.m. when someone's
I'm sure.
Let me schedule a meeting, and I'm like, okay.
Yeah, I'm on Mountain Time, and it's just past noon here, so I was like, oh, okay, that's not bad.
That's okay. Yeah, so my background is in software engineering. I did a bit of computer vision growing up in university. I did a MSc in outdoor augmented reality, and I've always been passionate about solving problems. I've never really been satisfied with just the status quo or this is good enough. And maybe that's informed the way that I've looked at the software that we have today and thought about maybe like what we could do better. Right.
Cool. Yeah, and I interviewed you for the Ruby Dev Summit. People can go check that out, rubydevsummit.com. But we talked about Async and Falcon, and I thought, there's some great stuff here that we should just talk about on Ruby Rogues, and then, we kind of got into future of Ruby and some of the things involved there as part of the summit. So do you want to just kind of give us the 10,000 foot view on Async, and then maybe we can get into what Falcon does in a minute?
So Async is an interface which gives event-driven concurrency to Ruby, provides event-driven concurrency. And it's always been designed as to give engineers like the best possible experience with concurrency. And so in that regard, that sort of mental model informed like a lot of the choices and the design choices. So Async provides task-based concurrency. It doesn't require any special keywords for asynchronous behavior, like say in JavaScript where you require async await. And it tries to be as efficient as possible, but it also sometimes chooses developer happiness over efficiency to make it easier. Because asynchronous programming can be pretty tricky, and giving people like good logging, good feedback when things go wrong, is really important, actually. And I don't think we've solved all of those problems, but
right.
But we're definitely like that's the mental model of Async. And so Async provides this event-driven concurrency, and on top of that, you can build other things. And when the first proof of concept that major proof of concept that I was really fascinated in was building a web server, because why not? And so that's what that's where Falcon came from.
Okay.
Falcon basically evolved from let's try it out and see what we can do with Async and what the performance is like. And then we can actually measure things and do some interesting real world comparisons.
So I have a question here that I'm kind of thinking about. And I mean, some of this, you said event driven, and that just made my mind think about, well, one, arguments that I've had with people over Node.js, but also, right, because they're like, events, Ruby. Anyway, but the other question I have is, way back in the day, we had Event Machine, and a couple of weeks ago, I interviewed Marc-Andre Cournoyer, who built Thin, and a lot of that was kind of built on some of the stuff with Event Machine. So, what's different between, say, Async and Event Machine, and then maybe Thin and Falcon?
Yeah, that's actually a great question. As an aside, I actually maintain Thin slightly. Thin was sort of languishing a bit, and I got involved in maintaining it, and I learned quite a lot about it as well. So I like exploring the ecosystem and seeing the different kinds of implementation. So to your point, Event Machine versus Async, or the modern version of Async actually has a gem behind it called IO event, and that's the actual event loop, the thing that provides the event loop. But surprisingly, or maybe surprisingly, Ruby actually has quite a rich history of event-driven architectures. It's not just event machine and like async. There's also celluloid, EM synchrony. Never block is one that many people haven't heard of, but was an interesting experiment.
I
It's
haven't
kind
looked
of
at some
similar.
of these in so long.
Yeah. And there's a handful of other ones. If I go digging in my notes, I'll be able to pull them out. But yeah. I suppose my point is there have been like a lot of keen minds in the Ruby community experimenting with this, and it's interesting to compare the different approaches. But I wanted to call out that there is actually a rich history there of people experimenting and trying to build things and looking at the different approaches. So specifically with, like, say, event machine and async, I think one of the challenges with event machine is that your event machine was written from the ground up with without really thinking about compatibility with existing Ruby interfaces. I think that would be the biggest criticism I could make of an event machine. And so when you build an application that uses event machine, you can't use normal Ruby IO. You have to use event machines, custom wrappers and classes to deal with event-driven IO. And I think for TCP, you get a class instance which has methods that get called back when data is available. And I think for UDP, it's similar but a little different. For things like sleep or timers, or all of these things, they're all event machine specific APIs. So I suppose to compare that with async, well, with async 1.x, because we were kind of in the same boat, we made wrappers for everything. So there's async IO, which is wrappers for Ruby's native IO. Async itself provides wrappers for things like sleeping. But there's other things which aren't wrapped, like DNS resolution in async 1.x. Process, waiting on processes. There's all these like different things that can cause an application to block and that we want to kind of lift into the event loop. So when I built async 1.x, I went to Mats, and that was the prototype. I was like, look, Mats, this works. People have done this before. To take it to the next level, what we need is actually hooks inside the Ruby virtual machine, so that when Ruby itself tries to do a blocking operation, we can hoist that into the event loop. And it has to happen at the core of Ruby. It can't be a wrapper that sits on the outside, because the problem with a wrapper is that as soon as you start using an existing application or existing code that uses native Ruby IO, that doesn't use the wrappers, and so it will block. And so you can't, it's sort of a compatibility thing. So event machine sort of suffers from that compatibility, I think. And so while event machine itself is generally quite okay, and was I would like to make an assertion that I think most event loops are roughly the same performance as every other event loop. Like, unless you massively mess up the implementation, event loops are largely on the same level of performance. There's very few things you can sort of do to make something like 10 times faster in an event loop. It's all going through the same operating system interfaces, roughly speaking, and there's a few choices you get to make in how you organize the user-facing parts. So, but there was one other issue that I had with event machine when I actually tried to use it, was that it would crash a lot, and it didn't support IPv6, or IPv6 would cause it to crash, or like something in that ballpark. And I think one of the problems with a lot of the existing like Neverblock and Celluloid and Event Machine and whatnot was that maintainers tried to bite off too much of the problem in one go, and I think that made it hard to maintain or even really specify the nature of what the problem these libraries were trying to solve, and the problem that got too big. And Event Machine was trying to reinvent every Unix interface under the sun, because it was trying to make them all non-blocking.
Right.
And it's just really hard for one person to do that. So another point of comparison is with async, especially async 1.0. I was really, really specific on what I wanted to achieve and what I wanted the interface to look like. And I got from async prototype to async 1.0 release in like 3 months. And I was like, this is one of the most important things for users, is to have a solid foundation that you say, hey, this is what it's going to look like for the rest of eternity, you can build on top of this without coming back in 6 months and having everything changed, or not working, or so complicated that we don't know how it's supposed to work. Or there's a lot of criticisms I could dish out, I suppose, and that it's not so much that software engineers working on these problems were like bad or anything. It's just more like the problem can be extremely complex if you don't compartmentalize it, I suppose. So the second part of your question was, how does Thin and Falcon differ? And so I think when you look at a server like Thin that's event-driven, Thin, I guess in some ways you could say Thin was pioneering, because it it introduced so in the Ruby world, when you have a web server, we have like an intermediate layer called rack. It's a gem which provides the bridge between a web server and a web application, and it provides a common interface based on the CGI specification, or like, some sort of like hybridized version of the CGI mashed up with a bunch of modern stuff.
Mark Andre and I talked a bunch about that in the interview we did with him. So
fantastic. And so Thin kind of pioneered what concurrency for a web app, like what the interface for concurrency might look like to a web application. And I think this was something which it feeds into the whole Rack 3 upgrade that we did over the past like 3 or 4 years. So the CGI model that we used for a long time was just request response. Here's a request that comes in, here's some headers, a payload, whatever, and then we're going to make a response and send that back out the wire. And that doesn't really work for things like WebSockets, or if you have 300 gigabytes of CSV you want to stream down the wire, because you can't really reasonably buffer 300 gigabytes of CSV.
Right.
And so Rack 2 did not provide any mechanism really for the kind of concurrency that Thin was trying to implement. And I think Thin pioneered what some of those things should look like. And so I don't want to say we took them wholesale, but we took the general concepts plus my own feeling on streaming, and we pushed that into Rack 3. So Rack 3 has a proper model, a standardized model for streaming requests and responses. That means when the request comes in, you can incrementally read what the client is supplying, and when you write the request back, you can incrementally write the response back out to the client. And this works for things like WebSockets. Like Perma on Rack 3 supports WebSockets out of the box on a request thread. And so this happened at the same time that I built Falcon. And so Falcon informed what Rack's interfaces should look like. And I think so Thin pioneered those interfaces, or the nature of some of those interfaces. And then we took that and we looked at, when I was building Falcon, I was like, how do we actually do this in a way that can work across all web servers? And so we kind of extracted that knowledge, standardized it in Rack. That took a couple of years, actually. Like, I'm not even joking. It was literally a couple of years to figure out what that was supposed to look like and get a release. And so Falcon basically evolves some of the conceptual things that Thin, as an event-driven web server, does. And the one other point is that I'll go back to compatibility, which is when you run an application on Thin and it uses, like, say, native IO, that will block Thin. So there's operations you can do in Thin that will be event-driven, and there's operations you can do in Thin that won't be. And I think things like EM synchrony, which try and provide the transparent wrappers, may help somewhat, but it's still not guarantee that you're going to have like the really good experience with Thin. With Async 2 and Falcon, because you have that interface right at the heart of Ruby, intercepting all those blocking operations, like waiting on a process, child process, DNS resolution, reading and writing from sockets, sleeping and timers, that kind of stuff. When you run an application on Falcon, it becomes transparently concurrent to the maximum extent that's possible on that particular implementation of Ruby. So it's kind of hard to say what is the difference, but that fundamentally, in a nutshell, would be like compatibility and just general approach to concurrency and the way it's exposed.
Cool, very cool. I see Valentino thinking. You have a question you want to ask?
Yeah, I did. So I'm curious, like the IO event. First of all, I love the async logo. I think that's hilarious.
Thank you.
For those that don't
Yeah.
know, it's a literal sink with a ruby coming out of the faucet.
Yeah.
That's great.
It's hilarious, isn't it?
But I guess I'm trying to understand maybe because I know the fiber schedule that you've made, right? Ultimately, that's made it into, I don't know what version of Ruby, 3.1.
Yeah, 3.1 was the first version of Ruby that had a full implementation of most of the critical hooks. And
so which aspect of async, of your async framework, like, is that piece of it?
So the IO, yeah, so that's a good question. So when I first built async, I was well, let me step back. As a software engineer, I prefer to build modular components. I find that there was an interesting observation I made when I was building. I used to work commercially on C++ projects, and there was an observation I made, which was the C++ build system is so complex in general that people would they'd build one package and then they'd be like, oh, it was so much work to build a package of like stuff. I'm just going to add more to this package. And so one package just grow bigger and bigger and bigger. Yeah, with like, instead of having small libraries that could work together, you'd have things like Qt, or there's a whole bunch of like C++ frameworks that just go from UI all the way through to like database and networking or something. And it's like, and everything in between, including like their own implementation of smart pointers and just like the whole everything. And it was just, as a commercial software engineer working on C++ projects, I just found this insanely frustrating, because you'd pull in one dependency for one little tiny piece and you'd get the whole kitchen sink. When I moved to Ruby and started working on Ruby in a more commercial sense and open source as well, I was like, wow, this is great. It's like so easy to make a package like a gem. And so I've always had this mental model that like the overhead of like trying to package up source code is like kind of inversely proportional, is that right, to like the size of the packages. So if it's, yeah, maybe I got that backwards. But anyway, like the harder it is to make packages, the worse the packages become in terms of scope and like compatibility and everything. So I was really inspired by Ruby gems and how simple Ruby gems makes it to build things. So when I built async and the things that came before, I always felt like I want to build small packages that work together, that are compatible, composable, easy to use. And the reason why is to avoid that multiplicative complexity that comes out of like huge code bases. And it's even hard to understand. You go to a code base that's 100,000 lines of code and you're like, where do I even start with this? Like trying to understand what problem the person was trying to solve and what they were thinking when they were solving it. So async,
so you're talking about, just to back up for a second, you're talking about something like if I wanted to use Active Record requiring me to pull in Rails to use Active Record as opposed to just having Active Record as its own little
I think if you go and look at
right?
if you go and look at other like languages, you'll find that in order to use like Active Record in whatever language you like if it was C++, let me just pull that example again. You wouldn't just be pulling in like a database adapter, you'd be pulling in like a whole, it'd be
full
pulling in like,
UI library,
like everything. Everything. Go and find like something which only does databases in an ergonomic way.
Right.
And like maybe Boost is another good example. I know that Boost can be used independently, but we pulled Boost into projects and it would add like 30 minutes to the compile time and like 30 gigabytes of temporary storage just for the like intermediate files. It's just like crazy. Anyway, so with async and gems that came before and gems that have come since, I always felt strongly I've got to compartmentalize this so it's easy for people to understand. And actually it was interesting because I've had that feedback from people. People look at the code and they're like, oh, this is easy to understand. Like I get it. And I learned a lot from your code. So I'm always happy to hear that feedback. Async won because it was really the proof of concept. It used an existing gem called NIO for R, which is an event loop that was, it's actually used by Rails now inside Action Cable. But the NIO for R is just an event loop interface. It uses libev under the hood, and it provides non-blocking I/O for Ruby. And it's the strongest thing about that gem is just how robust and long-lasting it is. It's been around forever. We have very few bug reports. It's solid as, like, it's a workhorse of IO, but it doesn't do anything else apart from IO, non-blocking IO. So it only does that part of the problem. Because that's the problem I was trying to solve in async 1, as a proof of concept, that's what we use. So async draws on NIO for as the back end, and it provides non-blocking IO. And you can build other primitives on top of non-blocking IO. Like if you want to do process wait and all you've got is non-blocking IO, what you do is you make a thread, you start your process on that, and then when the process is done, you have a pipe, like a notification pipe you write on, and the main event loop is just waiting on the other end of that pipe. And so that's when you know the process is finished running. So there are ways you can achieve, you can compose that together to achieve more complex behavior. In async 2, because that was more about, we've shown the proof of concept, and now it's all about performance. So async 1 and async 2 actually have exactly the same or very, very similar interface, like from the user developer point of view. But the back end is completely different. And so the IO event gem provides an event selector similar to NIO for R, but it's much more comprehensive. And it's quite the challenge to implement that across all platforms efficiently and support the wide range of features that we wanted to support non-blocking, like waiting on processes on BSD versus Mac OS versus Linux. It's all a little different. And so the IO event gem is where we multiplex out to the different operating system interfaces to do things as efficiently as possible. Does that answer your question somewhat?
Yeah, I think so. I guess that makes. I guess I'm trying to find the upstream Ruby aspect of it, and what you're bringing to, like, where does the fiber schedule itself get involved in that stack?
Yeah. Okay. So the IO event gem provides a class called selector, and the selector class provides a lot of the low-level interfaces for waiting on IO. So waiting for something to be readable or reading from something, waiting for a process to become to finish, and so it provides all these low-level implementations. And then async has a scheduler, and a scheduler has a selector. So the selector is something which I suppose you call it a selector because it's selecting things that are ready to go. And the scheduler is basically saying what's ready and then doing that stuff and scheduling the fibers to resume execution. So where the fiber scheduler interface comes into play is when you start an async block. At the top of that block, the async scheduler that's allocated as part of that block will register itself with Ruby as the fiber scheduler. And so then when you do operations inside that block, those operations will be redirected to that particular scheduler, which will then decide, do I need to delegate this to the event loop, the selector, and wait for something to happen or whatnot.
Gotcha. So, that's pretty cool. Have you found that certain platforms are more efficient at doing selecting or the scheduler is more efficient in certain platforms, or do you not even bother measuring at that level?
No, actually, I've spent a lot of time measuring at that level. It's a really fascinating problem area. So there's a couple of main implementations. On Linux, you have epoll and IOURIN. On Mac and BSD, you have KQ. And on Windows, which we don't really support very well, we have IOCP. And then for other platforms, we defer to Ruby's internal select, which is often implemented on top of poll, but not always. So to give you a very tangible example of where something is very different, but this is more of an interface thing than an operating system difference. And I'm actually not sure if this is still true today, because it's not something I regularly go and check, but the select interface on Unix can only handle up to file descriptors 1024. If you have more than 1,024 file descriptors in your process, select will break. And the reason for this is because, at least my understanding at the time, I looked at this, select uses a bit set. So it literally uses like a piece of binary data and it flips the bit 0 or 1, depending on whether you're waiting on that. And the challenge with that is every iteration on the event loop, you have to construct this bit set, like, hey, here's all the things I'm interested in, up to like whatever. And poll is the same, it's just a list. And then you supply that to operating system, and the operating system's like going to go through that list one at a time and say, hey, this is ready, this is not, this is ready, this is not. And so if you have, like, say, 5 connections, that's 5 things the operating system has to do. But if you have like 500,000 connections, that's 500,000 things the operating system has to do every time it goes through that like loop iteration to process like events. And so the reason why I mention this is because this is where you sort of have a fundamental performance difference in like the APIs. The most primitive APIs are linearly proportional to the number of like connections you have in terms of like actual individual operation to find out what's ready and what's not. But people found that was a problem. Like, people were trying to build high performance web servers and DNS and whatever else, and quickly ran into like limitation of this interface for event driven IO. And so we ended up with things like poll or epoll or KQ, where instead of giving that whole list to the operating system every single time you want to check for readiness, what you do instead is, when you monitoring a file descriptor, or like when you're monitoring something like a network connection or a web request or whatever, is there data available? What you do is you register that into the operating system and say, hey, when this thing becomes readable, you let me know. And then when you go through the event loop, instead of like providing that huge list, you basically just say like, yeah, I told you before, like if this thing comes ready, let me know. And you basically say, is it ready now? Tell me if something became ready. And and so we turn it into sort of like, instead of every iteration of the event loop being proportional to the number of connections, it's now just sort of a constant time operation, basically proportional to the number of ready connections, because you're going to get back a list that's the same size as the number of connections that have actions to occur. And honestly, that's pretty much what you'd hope for. And so KQ and epoll both work like that. And they're considered really the gold standards, I suppose, for high performance event driven networking. The biggest problem with those interfaces is that they are really geared to readiness-based notifications. Now, basically what that means is when you have a socket and data is coming across the network, when the data comes into that socket, the socket is now ready to be read, and you'll get a notification that says, hey, there's data available, you can read the request or whatever. If you try and extend that to the file system where you have files on disk, a file on disk is always readable. You can always read the data. It's not reading the data. You're not waiting for the hard drive to like, spin around and get to that point at the code level. What you're waiting for is the data to come off the disk and end up in a buffer somewhere that you can access. And that's, I don't want to say it's the slow part because it's actually pretty fast, but like, that's the part where you're waiting. And so the readiness-based notification kind of breaks there, because there's no easy way for you using epoll or KQ to basically say, hey, I want you to go and read this data and then let me know when it's available to be read. Like, there's no API for that. And so there was an original attempt to solve this called like AIO or Async IO, like at the Linux. And I think it was just considered really bad. Like, everything I've read about it is basically just don't use it. And I've not personally used it, so I don't really want to say like it's horrendous. But I think when I last read about it, what I read was that a lot of it was emulated in libc and was basically just mapping back to sequential reads and writes or something. So the evolution of this API from epoll is one that supports not just readiness notifications, but one that also supports completion-based notifications. There's 2 kinds of notifications. Readiness is when something is ready to start, and completion is when something is done executing. And so when you read data from a disk, you're not interested in waiting for the disk to become readable. Disks are always readable. you can always issue a read request on a disk, unlike a socket where if the data is not there, it will just stop. You'll wait forever until the data comes in. Completion base is when the data is ready to be used. And so Windows has IOCP, and Linux recently experimented with something called IOU ring, which is now gaining more traction. And in fact, I think IOU ring was so good, it was very funny. Windows actually copied it, and now Windows has their own IOU ring, which actually I tried to use it and it was like horrendous. I couldn't figure it out, how to get it to work at all. So in a nutshell, there's a variety of different interfaces. Fundamentally, what it comes down to is readiness versus completion, and having those different support for those different events. So in IO event gem, we do support IOU ring. It's actually the default on Linux now if you have an up-to-date kernel. And it will actually use, where possible, completion-based notifications for file system and sometimes network IO, depending on the circumstance. And so that's actually, funnily enough, it's not a huge performance win. As I mentioned before, event loops, much of a muchness. You're beholden to so many factors outside of your control. And as you asked, do I measure this stuff? Yes. And IOU ring, actually, when you really get down to it, when you really start trying to micro-optimize some of these things, there are some incredibly challenging insights that you derive from benchmarking and micro-optimization that I suppose they're kind of disappointing in a way as an engineer who's, when you're trying to actually get to that level. Mm-hmm. And then you finally realize, even though I did all of this, I ran into this wall here that I can't overcome. That can be a bit frustrating. And IOU ring, while it brings a lot to the table, still has a few things like that. And that's to me, actually, that's quite fascinating and what we do next. So,
cool.
Yeah.
So I kind of want to change the topic a little bit because, a lot of this stuff is fascinating to understand how things work under the hood. But these are not things that, at least in my, this is not things that I plan on touching, right? It's just like,
yeah, fair enough.
Okay, I know that there are little gnomes in my computer that are banging on this stuff, right? And you're teaching the gnomes how to bang on other stuff, right? And so I'm just going to run my Rails app or my Ruby, Ruby script or whatever on my machine, and it's gonna work its magic. So if we come up a few levels to kind of the level where I'm usually programming, right, where I'm either writing a script that does a bunch of things, right? And so then I have the async non-blocking IO stuff that's interesting, or things like that. Where do you see people using async in their own stuff?
Yeah, really good question. So it's interesting. Sometimes I hear about big companies using async, but they never really divulge much information. It's always fascinating to learn about different use cases.
I know. I want to play buzzword bingo with my projects too. I'm using AI and blockchain, and throw in a little bit of this and a little bit of that. I can't tell you what I'm working on. It's stealth mode.
Yeah, absolutely. So where I think async really shines right now is in applications that are IO bound, and that's especially true for things like API servers, proxy servers, anything like proxy gateways. So if you have, we just had someone recently talk to this. They migrated an application from, I guess, Perma to Falcon and async HTTP Faraday with a few minor changes, because I think that async HTTP Faraday supports persistent connections by default, so you need a little more bookkeeping in the application level. But and I think they saw half the latency, twice the throughput, and it halved their running costs. And so,
oh wow, okay,
this is the kind of and so there was a API gateway, if I recall correctly, and so this is the kind of thing where a request comes in, and it's basically just getting proxied through to a different system. And we've seen a variety of people with these types of systems in production having great success with the event-driven model. And I think a lot of these people, when I talk to them, they don't have to make many changes to their application, which was one of my original goals, was to kind of transparently try and go in there and make all of those IO operations non-blocking. But sometimes applications do explicitly want to opt into concurrency. Like sometimes concurrency is a performance thing, and sometimes concurrency is actually a functional requirement of an application. And I think it's important to be aware of those two distinctions. So where concurrency is about performance is if you have Falcon and it's just doing like net HTTP as an API gateway. You can run, like if you run that on Falcon versus Perma, you'll get better throughput on Falcon without any changes. So you improve your performance, but there's no actual change to your application behavior or anything like that. There are also situations where you might be like, hey, I have a deadline. Let's say you have some data that comes in and you want to sell it to the highest bidder. And so you need to know who's going to be the highest bidder, and you're never limited. Maybe the value of the data decreases over time. Maybe it's by the second. And so in that scenario, what you want is you want concurrency, because you want to talk to as many people who are going to pay for the data, find out who's going to pay the most, probably have a deadline on when they're going to reply by. So you need to have strong guarantees around the operational timing of all these like requests you're fanning out. And so async can do this too. This is where you probably use like a fan out MapReduce style approach, where you basically, hey, I have like all these, providers I want to talk to. I have the data that comes in. I want to fan it all out as quickly as possible. I have a 5-second deadline or a 10-second deadline. If they didn't reply by then, see you later, and then go through and figure out who's going to pay the most, and then finally ship the data off to them or something like that. Okay. And so we see use cases like this as well, where people are using concurrency at the application level to achieve things that would not be easily possible using other approaches. And what I say easy, like, look, if I'm completely frank, like, of course there are other ways to achieve this in Ruby, like threads and maybe even rectors, if you're lucky, if that works for you. But I wouldn't call them like easy. And I've certainly had experience with like other Ruby gems, which without a foundation like async, without kind of like a generic foundation, you have like gems like Typheus, which is an HTTP gem which can do multiple requests. But then you have like other gems which do the same thing, but they're not compatible because they all use different like event-driven foundations, and so they're not compatible with the server. They're not compatible with each other. So if you start trying to mix this stuff together, which I've seen, it just ends up like a huge disaster. So I think that's the value proposition of async, is it's a foundation on which if everyone, or and actually it's the fiber scheduler, which is the common interface. Async, what is it saying? Like, async is dead, long live async, or long live the fiber scheduler.
Right.
Async is a great user developer experience, in my opinion. But if you're building a library, you should target the fiber scheduler, not async, unless you really want to. Like, well, you can choose, of course, but and so when you run your web application on Falcon, not only should you see improved IO concurrency, so database queries will run in theory like at the same time. If you have like a high latency query, like that's not uncommon, then you forgot to put an index. It won't solve the performance of an individual request, but it will improve the concurrency of the whole application to the extent possible. But where it gets really interesting is when you start adopting that model in your application.
Yeah, I'm curious about that. Like, I mean, especially now that the Ruby world is still like very much dominant by Rails ecosystem, and there have been some more. I'm curious because Rails was not always like, runnable on Falcon, right?
Yeah. So
what was that story like? What were the challenges there, and like, is it okay now?
I don't normally tell the story in public because I don't know who I'm going to like upset, but I think it's about time I tell it. So when I originally went to
let me get some popcorn.
Yeah. Look, this is no criticism of anyone. It's more just a funny story, right. and it's probably fair enough that everyone had the opinions they did at the time and still do to some extent. But it's also a challenge for me, I suppose. When I first went to the Rails people and said, hey, can we support async or, Falcon or this concurrency stuff? And I didn't really get like a strong positive reaction. I didn't get like a hugely negative one. I mean, not everyone looks at it through the same lens that I do, and that's actually quite good. Diversity is often a good thing. especially in software engineering. Well, actually, I'm not sure about that, but tabs versus spaces. Yeah. Anyway, so I didn't want to push too hard on that and, cause more contention, I suppose. And so it was around that time when I was building Falcon. I thought, okay, well, actually, it's not Rails. The problem is not Rails. The problem is actually Rack. And it wasn't really a problem. Rack was not evolving at all, and it certainly wasn't evolving in a way that would support streaming requests and responses and whatnot. And so when I first started working on Rack, I think there were like hundreds of open issues. Like, it was just a project that had been stagnating, unfortunately. So I went through and I literally closed, I don't know, like maybe a couple hundred issues, pull requests, stuff like that. It was a lot of work. And I wrote in Jeremy Evans, who's amazing. And gosh, I would like, let me say, I think we're a great team. And I don't want to like take credit, because I think we've equally like been instrumental to the whole thing, but I want to say he's a great partner, a great teammate in this open source maintenance. And and so because I felt like it wasn't really worth trying to push too hard on Rails. So I went to Rack and I sort of solved all the problems there. And then we finally released Rack 3. And the great thing was I only needed to get consensus between me, Aaron, and Jeremy. And then we went to Rails and said, hey, Rails, here's Rack 3 and here's how it works.
Oh, nice.
And so then we made a bunch of pull requests to Rails to make it compatible. And that was basically objective truth at that point. So with Rails 7.1, with all, I think there was like maybe 10 or 20 pull requests that I made, now supports Rack 3, which means that Rails supports streaming requests and responses. It means you can drop a WebSocket in the middle of a Rails controller and have it work. And if you run it on Falcon, you get event-driven concurrency with that as well, which is pretty neat. So the challenges with Rails have been extensive. Rails has, I like to use the word ossified around the request per thread or request per process. And going in there with like request per fiber was kind of like, and so there were a lot of assumptions that we completely destroyed. And so now we have something called, one of the most critical pieces was done by, I think, sorry if I mispronounced this, like Jean Bossier. He implemented I think he implemented isolated execution state. Or maybe it was someone else. I can't remember, actually. I apologize to whoever implemented that. But it was a really fundamental feature to basically configuring Rails to, instead of storing its request state per thread, which on Falcon, every request runs on the same thread. So, of course, if you're sharing your request state per thread, you're sharing your request state with every other request at the same time. Instead, it isolates it to per fiber. And then that change has to percolate out across all the different systems in Rails. The biggest one is active record, which is also the biggest source of database, IO latency in lots of applications. And so right now, there's a pull request to address some of the issues that we've identified with the performance of active record on a fiber-based server. So I think Rails 7.1 is compatible, like fully compatible with Falcon. And Rails 8 will make it even better. And awesome. I think we're on track to seeing a much, let me just say, like, I think Rails 8 will just work, and it will just work really well.
Nice. So on a related note, where was I going to go? Oh, I remember. I'll let Valentino ask his question, then I'll ask my question. Sorry.
Yeah, I was just gonna say, like, I'm not gonna lie. When I first saw like Rails database, do it later, kind of, async. Yeah. I was very worried. I mean, having somebody just like sprinkle those around everywhere. In the state they released it at, it seemed like it was like a little too much magic for what it was doing. at the time, and I feel like a little better now that you've gone through the the state of things.
Well,
Because
can I
I
interrupt
know
you
I know
there?
we're still not quite there to just like, okay, everything's concurrency in Rails now. I know that's not true, but
Yeah. I want to just call out a little distinction there. You've mentioned a feature in Rails called load async. Is that what it's called?
I think
And there's
so.
a bunch. Yeah. I'm a little disappointed they chose this naming convention because it's actually load and background thread. It's not. It's got nothing to do with async, like the gem that I created. And while it might solve some problems, I actually had feedback from some people who tried it out on their applications and said performance was either the same or worse, and that it actually was hard to know when it should be used. So I think that the value of load async in Rails as it stands today, where it does a database query on a background thread, is when you can stack up several database queries that are slow and have them run in parallel. That's the key advantage. But the problem is there's only so far you can push that, I suppose. Even in Falcon, there's only so far you can push parallelism concurrency. And when you parallelize operations, instead of having the linear sum of the total time you have, you stack them on top to get the time is the slowest operation. But not that, I suppose in the real world use case, not that many people are stacking up queries like that, and knowing when to do it and where to do it is the challenge. And so with Falcon, we still essentially either do linear, or if you explicitly opt in, you can do the same thing like multiple database queries in parallel. But it's not just the individual request that, if you run that in Perma, you're still tying up the entire request thread. But in Falcon, that whole request will just get sat in the background until all the data from the database comes in, and then it will get resumed. So maybe in summary, like the performance characteristics of load async in Rails as it stands today, it's not really easy to have an intuition about where it makes sense. And that to me, like, it comes back to what I've said really at the start, which was building the good developer experience, or building the interface which is kind of intuitive and makes sense, is really like fundamental to this whole problem. Because concurrency is hard enough without trying to get users to think about these issues and trying to figure out where this makes sense or where it doesn't make sense.
Yeah, that makes sense. I'm gonna push us to another topic here really quickly. It's kind of related to some of this stuff where you, I think Valentino actually brought it up before the show, and then, I asked you about it heading in, and that is, he said something about you building Falcon into a platform that's more than just a web server. And
yeah.
where you started to discuss that, before I stopped and said, let's talk about this on the show, it sounded very interesting. So do you want to kind of plug into that and explain to people what you're looking to make Falcon into?
Sorry, just replying to someone.
It's the greatest keyboard.
Yeah.
Right.
Cherry Browns.
Yeah.
Look, so when I first made Falcon, as a proof of concept, I kind of squashed a lot of stuff into it, including. So there was a client HTTP and server gem called Async HTTP. That gem supports HTTP 1 and HTTP 2 today, and hopefully in the future supports HTTP 3. I've been working on it, but it's quite. HTTP 3 is like probably the most insanely complicated standard I've ever tried to deal with. So Falcon was kind of an adapter. Async HTTP there's a gem called Protocol HTTP, which provides a generic request and response semantic objects. So like the headers, the body, the status code, the version, that kind of the stuff that's the same across all versions of HTTP. And then Async HTTP takes that and puts it into makes the request and response run in an asynchronous task. So each individual request or response is operating concurrently. And then what Falcon did originally was adapt rack applications into async HTTP server compatible interface. And that was actually non-trivial, because there's things like rack hijack and like all the header mapping stuff and dealing with response bodies. That is there's like quite a few complexities in there to map a rack application to a straightforward HTTP interface. And after a while, I just thought, this is something that I actually want to use in a more generic sense. Like, mapping a rack application to an async HTTP server is not something that's Falcon specific. And Falcon became more about, so there's a gem that does this called protocol-rack. And protocol-rack provides all the mappings between async HTTP, or actually protocol HTTP, and rack. So you can take a incoming request that follows that very simple semantic format and map it into like a rack object, and then you can map it back again. And it does all the mappings for things like handling streaming requests and responses. So if you throw a WebSocket at it, it will work correctly, which is kind of important. So Falcon got split up into pieces. And so what Falcon does today is Falcon is kind of an application container. And what that means is there's a gem called async container. And async container lets you do multi-threaded, multi-process, or hybrid, or various other like ways of deploying an application and scaling that application. And what Falcon does is it just coordinates basically that container for like rolling restarts, blue-green deployments, these kinds of like things. And it has a configuration which basically just says, hey, I want you to host this rack application on port whatever. And so you can run any application in there. It doesn't have to be a rack application. You can actually run a native async HTTP server compatible interface application, and Falcon will host that. And you can actually host multiple applications inside one instance if you want. So it's just basically a container now for hosting applications, and all individual pieces are just connected together. And so where I think this goes next is I quite like to see us simplify like Rails deployment. Yeah, this would be like, if I was to put a goal to it, it would be simplifying Rails deployment. And I think there's been a lot of work in this area, but it's still quite challenging. Like, you need a database, probably you need Redis, you probably need background job runners, you probably need obviously a web server usually. Mm-hmm. Sometimes you get other things running in the background there. And we've had things like, what's that tool called that starts multiple processes? Gosh, I forget. There's a couple of gems which will coordinate all these processes for you. But I wanted like Falcon to do that. Yeah, Foreman, that's the one. Yeah. And so I've used that in the past, and it works okay. But I felt like it's still quite difficult to deploy a server. And so what I wanted is I wanted to like have a self-contained application. So a Falcon application that includes like a job server. And you basically just go, here's my hardware, go and run this. And you have to think about
that'd be so nice.
I think even Action Cable can be quite tricky to deploy. You know, like with Action Cable, often you have like any cable, or you have Puma that's a dedicated instance of Puma running on a different port. There's just like all these like funny, tricky things that have fallen out of the assumptions we've made about how things are going to be deployed. And I feel like if we just step back and go, hey, what problem are we really trying to solve here? Falcon can better address those by exposing kind of this, application host-based model where you basically go, well, I need a job server, I need a web server, I need this server, that server, and I'm just going to start it all up and now my application is running.
Yeah, in fact, for my development stuff, I started out with the Tailwind CSS gem for Rails, or I guess it's Tailwind CSS-Rails, right? And so when you install it, it installs the bin dev executable, which effectively calls out to Foreman and says, hey, run the Tailwind watcher alongside the web server, right? And so then as I've added in full text search and things like that, right, now it spins up the full text search engine and right, all the things that have to go into all of that stuff. And so anyway, just kind of throwing that all together, it'd be really nice to be able to deploy that way, because when I deploy, it's okay. And I'm using Kamal. And so I need an accessory for this and an accessory for this. And then I need two app servers. One of them's the app server and the other one's the job server. And,
yeah.
Right. And so it orchestrates like 6 or 7 different Docker containers across 3 or 4 servers to do all the things that I need. And yeah, it would be beautiful to just be able to run all or most of that under a, hey, I've got this application that runs like this. And then sure, maybe I have a caddy or traffic load balancer out there that I have to manage separately. But yeah, anyway.
I think we've made things too complicated.
Well,
like,
so David DHH, when he gave his Rails World keynote, and he was talking about all the different things that are going into Rails, and he talked about, hey, we got this and we got this and we got this, and then specifically he got into the asset management for Rails. And what he said was, we picked up Webpack and Webpacker because it was kind of the most comprehensive way to do it, and it did everything that we wanted, but it was complicated and gross and hard to use, right? And so what he pointed out was, but we had to take that step in order to get to where we got to with import maps and prop shaft. And so when I look at it, it's like, yeah, we've kind of done things in a way that is not exactly the most friendly way. But I think what it's done is it's kind of given us the tools for, okay, we know that we generally need all these things now, and we know how to run them all. So yeah, unify the interface.
I think,
but it's an essential step to getting where we are.
Yeah, to your point, I think to know the happy path, you have to know the unhappy path.
Yeah. Well, sometimes you get lucky and you can just happy path your way through it. But
yeah, but then you don't know. Then you don't really know how happy or lucky.
Yeah.
You are, because you never really experienced the pain of like doing it.
Yeah, true.
The other way.
Very true.
I mean, that's kind of the like the negative of Rails as a framework, right? Is it provides all this magic, and if you specialize in knowing the feature, then it then you need to know, right?
Yeah,
like
then
otherwise,
you go pick up Sinatra,
forget about it.
It's like,
yeah, but like, okay, well, if you run into like an edge case, well, and the person that is expert like is unavailable, then like you're spinning your wheels trying to figure out how it all works.
I mean, I want to talk to the specific point. A long time ago, I did Objective-C development with Apple's like frameworks, and they were completely opaque. There was no source code. If your like NS table view didn't work correctly, there was no way you'd be able to figure out like why the thing was rendering wrong or why the column was in the wrong place, because you'd put a breakpoint and it would just, there's nowhere else to go. And I really want to call out like how amazing Ruby and Rails is. I mean, of course, open source projects are all similar in this regard, I suppose. It's part of the definition of having the source available. But it's just so refreshing if you've had that experience, that pain, to be able to go into the source code all the way down to like the interpreter. I mean, occasionally I do find bugs and I'm digging in the interpreter, putting like fprintf statements, trying to figure out like what's going on. We're so lucky to have that, and I want to call it out because like maybe people don't realize, like, if all you've ever done is use Rails and frameworks where all the source code is available, you may not have experienced the level of pain that comes from using closed-sourced frameworks or libraries or whatever systems. And it can be extremely painful when you're trying to debug an issue. Like I'm talking like multiple weeks with multiple engineers trying to like figure things out. So we're extremely lucky with Rails in that regard.
Yep, absolutely. Well, we're kind of getting toward the end of our scheduled time, as far as usually picks take up a little bit of time. So really quickly, if people want to...
Can we get to one quick thing? Because I just saw that Samuel released like this spike on async job, which is like one of the most requested like things I've been waiting for is for something like this to surface. Do you want to just give a quick like TLDR of what that is and maybe how people could get involved?
So I think Rails has done a pretty good job of abstracting out an interface for job execution. And I think Mike did a great job of creating Sidekick. And I think we've converged on what that looks like now as a user interface for application developers. Mike's work was really pioneering, I think, in lots of ways. And async job, Sidekick uses multiple threads usually for executing multiple jobs, which is perfectly acceptable. And I think he'd like to also use reactors if possible. I think that's still a way out. But async job is basically runs on a similar principle, uses Redis. I'm hoping to also add like a database backend as well at some point, maybe SQLite or just generic database layer. And then it basically lets you schedule and execute jobs. And so my goal is to have this provide, so on the client side, it will provide like a active job adapter, and that will probably be the most common use case, I would say. And then on the back end, it will just use async, and probably I'll make it very easy to spin up as part of a Falcon application. So you have to basically say in your Falcon configuration, hey, I've got a web application and I've got a job server, and have that just execute and coordinate as efficiently as possible. So yeah, async job is something I've been meaning to work on for a long time. I just didn't really have the bandwidth for it. But the current Spark is looking quite good. Like it's I think async. Maybe to give an interesting context, I often work on the library of async. So I'm not that often like a consumer of async. But with async job, I was kind of a consumer of async. There was a very fundamental part of async job. And so I had like that good experience that I was trying to, from the other side. It was really straightforward to write the code. Redis just worked. It was easy to do like quite complex things with Redis, like have a heartbeat, a job server with a heartbeat, which then recovers jobs if the server dies. So a bunch of this functionality, it was all done in sort of like, maybe 100 lines of code, 200 lines of code. And if you compare that with, I know that Sidekick does a lot more, but Sidekick also has a lot more lines of code. And I'm a big fan of like less lines of code equals less bugs. So
yeah, totally.
Keeping things like small and simple is really admirable, I think.
Yeah. Well, cool. I'm looking forward to seeing more progress on that because I I feel like that's the one thing as Rails app grows is you try and figure out how to execute all your jobs faster.
Yeah.
You guys drop a link to that in the comments. It goes out to Facebook, YouTube, and Twitch, not Twitter or LinkedIn if you're over there. Awesome. All right.
I can do that.
Yeah, it looks like Valentino dropped it. All right.
Cool.
Well, I'm going to push us toward picks and wrapping up the show then. But before we do that, Samuel, if people want to connect with you, if they have questions or things they want to do with Async, how do they find you?
The best way to do that is through GitHub discussions. I have a personal GitHub discussion under GitHub/iAquatics. But if it's async specific, then just go and find the project on async and use the discussion.
Okay.
There's a whole bunch of early adopters and fantastic open source maintainers and contributors who will, if I'm not available, will jump in usually. And to me, that's amazing. But so that's the best way to get in touch. And the great thing about that is we're building a knowledge base. So you might want to do if you've got a sort of a technical question, then doing a search first might help out as well.
Awesome. Well, we'll put a link to your GitHub in the comments, and then my team can pull them out and put them in the show notes. Let's go ahead and do some picks real quick. Valentino, do you have some picks?
Sure. So I love hacking on hardware in my free time, and I came across this. Somebody made an open source wearable AI device that uses the Cora AI embedded system, and I'm real Coral.ai. So I'm really I got a whole set of things that I'm gonna try and use a Raspberry Pi Zero or Pi W and the Coral and fuse them together and hope that I can like make my own like wearable AI device. And so he has a whole project down. I forget the name of it. I'll put it in the show notes though. But I'm looking forward to building that next weekend.
Very cool.
That sounds awesome.
Yeah. I'm going to throw out a few picks here myself. The first one is I always do board game pick on the show. So last night I was hanging with my friends and one of my buddies bought a new game. And so, of course, we played it and it was awesome. It's called Fire Tower. Came out in 2019, 2 to 4 players. We played it with 4 players, just to put that in there. We were kind of time limited, and I think it took us an hour, maybe a little more than an hour to play it. Hour and 10, hour and 15. And that was with us learning to play the game and playing the game. And effectively, the idea is each player has a tower in one of the corners of the board, and then there's a wildfire in the middle of the board. And you take turns. So the wind's blowing in a particular direction, so you add a flame token to the board in that direction from any other flame token, right? It has to be next to it. But then you play a card, and so the cards can put out fire. They can expand the fire. They can change the wind direction. And so the way you win is you take out everybody else's tower. So you move the fire toward them and away from you is kind of the deal. I really enjoyed the game. I will also point out that I won the game by taking out each of my friends one at a time. When you're eliminated, you are the spirit of the forest, and so you roll the die for the direction of the wind, and then you have different actions you can take. So north lets you, I think, put a fire token out, or one of them lets you change the direction of the wind. One of them, anyway. So it's way fun. It was a lot of fun, and so, but it's relatively simple. Board Game Geek weights it at 1.79. Which means a very easy casual game. So I'm digging that. It was a ton of fun. So I'm going to pick that. If you're in Utah, I think it might be sold out, but if it's not, I'm going to SaltCon in a couple of weeks, 3 weeks. And SaltCon is a board game convention in Davis County, so just north of Salt Lake. So if you want to come play games with me, let me know you're going, and that'll be fun. I'm heading up with one of these buddies of mine. And anyway, fun. So excited about that. I also have the Ruby Dev Summit videos up. If you go to rubydevsummit.com and you put your email address in, you can get access to the videos for 24 hours. They incidentally have also been going out on the Ruby Rogues feed this week. But I plan on taking them back off of the feed. And so if you didn't get them, you didn't get them. And I'm sorry. But just go to the webpage and we'll hook you up. Just trying to think what else. I mean, mostly just been heads down working on Rails clips and Ruby bits. And so if you're looking to learn more Ruby or Rails stuff, go check out the videos there. And I'll wrap it there. Samuel, what are your picks?
Sorry, you're going to explain this concept to me. I'm not familiar with it.
No, it's okay. So every show we just pick stuff that we like. So if it's
really?
stuff you're enjoying. So yeah, so if it's a TV show. So another one I could pick, my wife and I watched Only Once on Netflix.
Yeah.
Right? And,
okay,
and that
TV
was a fun
show.
series. So TV show, board games, tech stuff, whatever.
I've been watching Futurama. I'm really happy they revived that show. It's just like hilarious.
Nice. Such a great show.
Yeah. I suppose what's great about Futurama, or at least I don't know about the latest version, the latest season, it's not too bad. But the early ones, they're all apparently they had more years of PhDs in the room than you could be alive for one lifetime. And the stories were always really, the characters in the stories were always really hilarious. So yeah, Futurama, go and watch it.
Awesome.
You probably won't be disappointed.
That's one that's always been on my list, but I never quite get around to.
You haven't watched it? Okay.
I've watched it with my kids a couple times, and it's a huge hit.
Yeah.
Some of them you have to be like, maybe we shouldn't watch this anymore.
Yeah, some of it looks like some of the humor might be a little bit off color.
But yeah.
It looks freaking funny.
Very clever. There was one episode where they actually published a mathematics paper because they solved a mathematics problem. It was like a Professor Farnsworth invented like a brain switch, like a head switching machine. But the point was, once you'd switched with one person, you couldn't switch back. And they actually had to invent a new mathematical theory to show that it was possible to switch back. And they published it as part of the show, I think. Yeah.
That's really funny.
Very cool. All right. Well, thanks for coming, Samuel. This was a ton of fun. Such interesting stuff.
Fantastic. It was a pleasure to be here and to answer some of your questions.
Yeah. All right. Well, we'll wrap it up here. Till next time. Max out.